Hi everyone, today will be the first in a series of videos for secondary math, and this is applicable for secondary 1 grade in Singapore or grade 7 for other curriculum as well. So what we are going to see today is about the numbers, and there are different types of numbers. There's factors and multiples. We are going to see what are factors and multiples. Let's take factors first, and let's take a number 12. What are the factors of 12? Factors are the numbers that can divide 12 without a remainder. For example, 12 times 1 is 12, which means both 12 and 1 are factors of 12. And 6 times 2 also gives us 12. So 6 and 2 are both factors of 12. Similarly, 4 times 3 gives us 12, and so 4 and 3 are factors of 12. If you divide 12 by any of these numbers here, the remainder would be 0. So then you call these as factors of 12. So the factors of 12 are 1, 12, 2, 6, and 3, and 4. So these are factors. So factors are numbers that can divide a given number without a remainder or a remainder of 0. Now let's look at multiples. Take the same number 12. See, 12 times 1 is 12, times 2 is 24, times 3 is 36, and so on. So these numbers 12, 24, 36, these are called multiples of 12. Of course, 12 is already there, so 24, 36, and 48, 60, all that are called multiples of 12. So the multiples of 12 would be like 12 times 1 is 12, times 2 is 24, times 3 is 36, times 4 is 48, and times 5 is 60, and so on. It goes on. There's no end. It can go on up to infinity, and all these numbers are called multiples of 12. And these numbers are called factors of 12 because they can divide 12 without leaving a remainder. Now let's look at numbers and see how there are many ways in which numbers can be classified. We will just see one such type. Numbers can be classified as prime numbers and composite numbers. So what are prime numbers? The prime numbers are numbers that have only two factors, that is, 1 and itself. For example, 2, 3, 5, 7, 11, 13, and so on. These are called prime numbers. If you take 2, for example, it can be divided by 2 and 1. That's it. It can be divided by 2 and 1. And this is what we mean by it can have only two factors, 1 and itself. Here 2 is itself, right? So 2 and 1 are the only factors. There are only two factors, so this number is called a prime number. Similarly for 3, 3 times 1 gives 3. So 3 and 1 are the only factors for 3. So that makes 3 a prime number. Same goes for 5 as well, and for the rest of the numbers that you can see here. Now, what are composite numbers? Composite numbers have more than two factors. So they have 1 and itself as a factor, and in addition to that, they have more of the factors. Examples: 4, 6, 8, 9, 10, 12. Let's take 4 for example. 4 and 1 are the factors, that is 1 and itself, and in addition to that, this should be 2 times 2. There's an error. 2 times 2. So 2 times 2 also gives us 4. So 2 is an additional factor for 4. So factors for 4 are 1, 4, and 2, so that's more than 2. So 4 is a composite number. Similarly, let's take 6. 6 times 1 and 3 times 2. So we have 1, 2, 3, 4 factors for 6. Same for 8 as well, 8 times 1 and 4 times 2. So we have 4 factors here for 8. So composite numbers are divisible by more than 2 numbers. That is, other than 1 in itself, they have additional factors. Another way of classifying numbers would be to call them as even numbers and odd numbers, or odd numbers and even numbers. So what are odd numbers? Example for odd numbers are 1, 3, 5, 7, 9, and 11. The difference is always 2. So these are called odd numbers. And even numbers, example 2, 4, 6, 8, 10, 12. Again, here the difference is also 2. And 0 is neither even nor odd. And the reason is for that is beyond the scope of today's lesson. So we will not go there. So just remember 0 is neither even nor odd, but the rest of these numbers 2, 4, 6, 8, these are all called even numbers. Mainly because when we talk about even distribution or even cut 2 pieces evenly, meaning 2 equally. So we can cut these numbers equally into 2 equal pieces. For example, 2, 1 and 1, 4, 2 and 2, 6, 3, 3. So we are able to divide them evenly. So they are called even numbers, whereas this cannot be done that way. So they are called odd numbers. And one interesting property here, odd numbers are not divisible by 2. You cannot divide these numbers by 2 without getting a remainder. Whereas even numbers, all even numbers are divisible by 2. So the moment you have an even number other than 2, then you can actually say that that number is definitely not a prime number because they are all divisible by 2. Then sum of 2 odd numbers gives an even number. For example, 1 plus 1 is 2, which is an even number. These two are odd numbers. Right? Sum 1 plus 3 is 4. So that's an even number. So sum of 2 odd numbers, remember, not sum of odd and even. It's sum of 2 odd numbers gives an even number. Again, 5 plus 3 gives you 8. Similarly, sum of 2 even numbers, that also gives you an even number. 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 8 is 14, and so on. So remember, sum of 2 odd numbers or sum of 2 even numbers, that is, both numbers are of the same type here, odd and odd. Here, even and even. Then the result is an even number. What happens if I have to add an odd number plus an even number? That gives me 3, which is an odd number. So that's the other rule. So if you have an odd number plus an even number, that gives you an odd number. Another example, let's take 2, which is an even, and 3, which is an odd number. That gives us 5, which is an odd number. So these are some interesting facts that you can keep in mind. Now what we are going to do is, this is an exercise to find out prime numbers. So we are going to find out in this numbers that are given here, how many are prime numbers. So let's take 2 for example. We will see all that numbers that are divisible by 2. We will not, of course, include itself. So we are going to not include itself. But other than that, we know that 2 is a prime number because it only has 2 factors, 1 and 2. 3, no. And what about 4? Yes, 4 can be divided by 2 without a remainder. And then 6, 8, 10. These are all divisible by 2, and you see the pattern there. These are even numbers, right? Again, 12, 14, and so on. So we are just going to cross out all these numbers. All these numbers are divisible by 2. So all even numbers, they are not prime numbers. So now let's take look at what are the numbers that will be divisible by 3? Or in other words, we're going to look at multiples of 3 and see if they are here. So leave out 3. 5, 7, 9 is divisible by 3. Yes. And 11, 13, no. 15 is divisible by 3. And 21 is divisible by 3. And 27, and so on. We have crossed out all those numbers that are divisible by 3. Now, should I check if there is a number that will be divisible by 4? Actually, no. Reason why? 2 is a factor of 4. So, we have actually, if there is any number left there, that will definitely be divisible by 2. So, 4's numbers would have been crossed out because we already did for 2, which is a factor of 4. If you want, you can just take some examples. 4 times 1 is 4 crossed out. 4 times 2 is 8 crossed out. 4 times 3 is 12 crossed out. 4 times 4, 16 is crossed out. So, if you know that if you have a number, then if a number is divisible by 4, then that number is also divisible by 2, which is a factor of 4. Now let's take 5. We will not consider this, but then after this, is there anything that we need to look at? Yes, 25 is divisible by 5. There is 15 and 10 that has already been crossed out, so 25 was left, and then we have 35. 5 times 7 is 35. And all the other 55, 65, 85, and 95. So all these are cancelled out as well. So now 6. Do we need to check for 6? Actually, no. Why? Because 2 and 3 are factors of 6. So if a number is divisible by 6, it is definitely divisible by 2 and 3, and we would have crossed out here. Let's check some of the values. 6 times 1 is 6 crossed out. 6 times 2 is 12 crossed out. 6 times 3 is 18 crossed out. And so on. 7, yeah, we have to try 7. Now, 7, this one, we will not take itself. So after that, if you just go a quick scan, 41, no. 49, yes. 7 times 7 is 49. Actually, this should go in addition to 7 times 11, which is 77. This has gone here. Alright. Now, should I check for 8? No, because I've already checked for 4 and 2, which are factors of 8. Should I check for 9? No, because I've already checked for 3, which is a factor of 9. And I can check for 10, but let's see, 10 would already be crossed out because 2 and 5 are factors of 10. So now, when we have completed all this, what the numbers that are remaining will be prime numbers. 2, 3, 5, 7, all these are prime numbers. This is a small exercise to more clearly understand what are prime numbers. I mean, we have only included up to from 1 to 100. So these are the prime numbers. So, hope this was helpful. Now, let's take up a sample question. Determine whether each of the following number is a prime number or composite number. This, we know that it's only 2 times 1 is 2. So, the conditions are they have only 2 factors, which is 1 and itself. Then it's called a prime number. Yes, this is a prime number. Here, 15 times 1, yes, but in addition to that, we also have 3 times 5. In addition to 15 times 1. So, this is not a prime number, so this is a composite number. So, let's come to 17. 17, again, I have 17 times 1. But I do not have any other number that can divide 17. So, 17 is a prime number. 21. 21 times 1, but I also have 3 times 7. So this is a composite number. 27. We know that 3 times 9 is 27. The moment you know that there is a number other than 27 and 1 that can divide it, then we know it's a composite number. 29. This is a prime number because other than 29 and 1, there are no other numbers that can divide this without a remainder. Let's move on to the next question. Find two prime numbers whose sum is an odd number. If you can figure this, please write your answers in the comment section. I will later post the answer. This is just an exercise for you for fun. Try it out and see if you get it properly. One clue is that if you go back and find that when you can an even number be a prime number? Once you figure that out, I think pretty much easy for you because yeah, I'll leave that to you. Let me see. Even number plus even number gives you an even number. Say odd number plus odd gives you an even number. And remember, once a number is even, it is divisible. Other than 2, right? 2 is the only even number which is a prime number. And so if you get an even number greater than 2, then it is always a composite number and not a prime number because it is divisible by 2. So let's see. We cannot use 1 here. 1 is neither prime nor composite. So we have to start from 2. Let's say 2 plus 3 gives us 5. 5 is an odd number. And 2 is a prime number. 3 is also a prime number. So the answer is 2 and 3. I've given you the answers there, so you don't have to sweat it out. Let's move on to the next question. If a number is divisible by 8, should it also be divisible by 2, by 4? Explain your answer. We have seen this earlier. 8, 2 times 4 is 8. 2 is a factor of 8 and 4 is a factor of 8, which means any multiples of 8, which is 8 times 2, 16, will be divisible by 2 and 4. Similarly, 3 times 8, 24. These are numbers which are divisible by 8, which can be divided by 8 without leaving a remainder or leaving a remainder of 0. So these numbers can also be divided by their factors of this number. So that is what it means. So since 2 and 4 are factors of 8, since 2 and 4 are factors of 8, any number that is divisible by 8 will also be divisible by 2 and 4. I hope this was clear. Let's move on to the next part, prime factorization. So what is prime factorization? Take a look at this. You have prime. So there are some prime numbers involved. And factorization. So basically factors. We have learned what are factors. So those kind of numbers are going to be involved as well. Let's take a number, again 12. I don't know, I like number 12, I guess. So if I'm going to divide this number by a prime number, 2 is the smallest prime number, so I'm going to take 2. 2 times 6 is 12. Now 6 is not a prime number. So I'm going to divide this further. I can divide it by 2 because it's an even number. 2 times 3 gives me 6. And 3 is a prime number. So all these numbers here at the last level are prime numbers. So not only that, these numbers can divide 12 without giving any remainder or give it a remainder of 0, which means 2, 2 and 3. These are all factors of 12. So factorization means expressing the number as in terms of its factors. So 2 times 2 times 3. So this is prime factorization. 3 is a factor of 12 and 3 is also a prime number. 2 is a factor of 12 and it's a prime number. The other two, when you multiply all these, you get 12. So each of these are prime factors of 12, and this process of expressing a number in terms of the product of its prime factors is called prime factorization. Hope that was clear. Oh, let's take another number. Let's say 45. The first number in terms of prime number that comes is, since it ends with 5, definitely it's an odd number, so it's not 2. 3 possibly yes, but I know 5 is definitely going to divide this number. So 5 times 9 is 45. And once you see 9, you know 3 times 3. So 45 can be written as 5 times 3 times 3. So that's the prime factorization process. And you want a bigger challenge? Let's try 1 over 28. See, even if you have bigger numbers, if it's an even number, I know for sure it's divisible by 2. 2 times 64. 2 times 6 is 12, times 4 is 8, 64. And again, it's an even number. So I can divide by 2, so 32. It's an even number again, 2 times 16. It's an even number again, 2 times 8. That's an even number, 2 times 4. That's an even number, so 2 times 2. Wow. So 128 can be written as 2 times 2 times 2 times 2. How many 2's are here? 1, 2, 3, 4, 5, 6, 7 2's are here. So 2 times 2 times 2 times 2 times 2 times 2 times 2. So that's the prime factorization of 128. Yeah, one sample problem here. Express 252 in prime factors. We'll use the same method. 252. It's an even number, so I'm going to divide it by 2. So that would be 2 times 1 is 2. 2 times 2 is 4. 1 gets carried over 12. 2 times 6 is 12. So again, it's an even number, so I can divide by 2. 2 times 6 is 12 and 2 times 3 is 6. Now this is an odd number, so definitely not divisible by 2. But I know that it is divisible by 3. 3 times 2 is 6, 3 times 1 is 3. Again, 3 times 7. So this can be written as express 252 in terms of its prime factors. So 2 times 2 times 3 times 3 times 7. So that's the answer for this question. Now we come to a concept called index notation. We did just now finished we did a prime factorization of 252. Let's do that once again. 2 times 1, 2, is it 2? Yeah. 126, and then 2 times 63, 3 times 21, 3 times 7. So these are the prime factors. So I can write it as 2 times 2 times 3 times 3 times 7. Now, index notation is a special way of writing. If the number is very big, then we'll have to keep on writing so many of these numbers. So instead of that, what we can actually do is group them together. 2 times 2 is the same as 2 to the power of 2. 2 to the power of 2 is 2 times 2. Similarly, 3 times 3 is the same as 3 squared, or 3 to the power of 2. And we have times 7. So if the question asks you to express your answer in index notation, or write your answer in index notation, then you just have to write it like this. So let's take another example. Let's say 270. So I know that it is divisible by 2 because it's an even number. So 1, 3, 5. Now it's an odd number, so definitely not divisible by 2, and maybe 3 times 4 is 12, 3, 5, 15, and we know this is 5 times 9, 45, and 3 times 3. So 270 can be written as 2 times 3 times 5 times 3 times 3. So in this case, rearrange and write them so that 2 times 3 times 3 times 3 times 5. So since we have 3 3's, we can write it as 2 times 3 cube times 5. So that is about index notation. So remember, if you say 2 power 4, that is actually equal to 2 times 2 times 2 times 2. So 3 power 5 means 3 times 3 times 3 times 3 times 3. Please remember, it's not 3 times 5. That's totally different. So this is what you get. When you add numbers, 3 plus 3 plus 3 plus 3 plus 3. When you add 5 3's, that becomes 3 times 5. Here we are multiplying the numbers here. So this is one thing that you have to keep in mind. Express the following using index notation. 7 times 7 can be written as 7 square, 7 to the power 2. Here we have 2 2's and 2 5's. So 2 square times 5 square. And here we have 1 3 and 3 7's. So 3 times 7 cube, or 7 to the power 3. Here we have 3 5's and 3 11's. So 5 cube, or 5 to the power of 3, times 11 to the power of 3, or 11 cube. 5 times 5 times 5, and I have 2 29's. So I can write it as 5 to the power of 3 times 29 to the power of 2, because I have 2 of them, and then times 19 times 23. I hope this was clear. Factorize each of the following numbers into prime factors. So let's take this example 100. It's an even number, so it's definitely divisible by 2. 2 5's 10, and it's 250. 2 times 50 gives you 100. Again, this is an even number, so 2 times 25 gives you 50. Again, this is 5 times 5. They are just saying factorize each of the following into prime factors. So all we need to do is write this number as a product of its factors. 2 times 2 times 5 times 5. So this is equal to 2 times 2 times 5 times 5. So here 125. So we use the same thing. I want to go with 5 first, because 5 times 25 I know is 125, and then this is 5 times 5. So this is 5 times 5 times 5. 147. Let's take 147. It's an odd number. So let's take 3. It's not divisible by 2, but I think it's divisible by 3. 3 times 4 is 12. So in 14, 12 goes, remainder is 2. 2, 7, 27. 3 9s, 27. And this clearly we know that is 7 times 7. So the answer is 3 times 7 times 7. And lastly, we have 216, 2. It's an even number, so definitely it's divisible by 2. 2 times 10 is 20, so we have 16. 2 times 8 is 16. So 2 times 108 gives 216. Again, divided by 2 because it's an even number. 2 times 5 is 10. 2 4s 8. Similarly, even number. 2, 2, 7. And this goes as 3 times 9. And this 9 goes as 3 times 3. Yeah, sorry, there's not enough space there. But 2 times 2 times 2 times 3 times 3 times 3. So that's the answer here. So we are having 2 times 2 times 2 times 3 times 3 times 3. So that's the answer for this question. Now we are going to see highest common factor. Whatever you need to know about this is already there in the name. It is the highest and common factor. It's in some curriculum they also refer to this as greatest common divisor. Divisor means the number that can divide. So that is here, factor. And common is there. Here it says highest, here it says greatest. So because we are talking about something common, we have two numbers. We are going to see what is the common divisor of these two. Let's take 30 first. 30, 3 times 10 is 30. So what are the other ways of finding, what are the other factors of this 30? 30 is 6 times 5 is 30. 30 is 2 times 15 is 30. So these are the factors. Say 2, 3, let me write them in the order. 2, 3, 5, 10, and 15. So these are the factors of 30. Now, we are just learning it, so do not worry. There is a simpler method of finding this. I'm just writing down the factors like this. But later we will see how to easily do this without going through this tedious process. 36. Let's say 36. What are the factors of 36? 2 times 18 is 36. Then we have 6 times 6 is also 36. 4 times 9 is also 36. And 36. 3 times 12 is also 36. So let's write them down. I think that is all. 4 times 9 is 36. Yeah, pretty much all that we have. So 2, 3, and 4, 6, 9, 12, and 18. So what is common? 2 and 2 are common. 3 and 3 are common. But 6 is also here. Because 6, 5 is 30. I think I missed out 6 here. 5, 6, right? 6 is here. So 2 is common, but that's not the highest. So 3 is also common. Is there any other number that are common here? 6 is common. After 6, we don't have anything that is common here. So 6 and 6. This is the highest common factor. Do not worry, we will really find out. This is just for understanding purposes. You know that why we call that as highest common factor. Now let's later see how to actually find the HCF. This is the first method we are going to see how to find the LCM. Let's say 12 and 20. What we can do is first take out for 12. 12. 2 times 6. 3 times 2. So these, I can write 12 as 2 times 2 times 3. I'm just grouping them together. 2 times 2 times 3. Similarly for 20, you know that 2 times 10 and 2 times 5. So 20 can be written as 2 times 2 times 5. So remember, see why I'm pushing this away is because I'm just giving space for this 3. So now what we do here to find the highest common factor is that we actually take up those that are common to both of the numbers. So 2 times here both of the numbers 2. And this 3 is not here, so I'm not doing anything about it. And 5 is not here, so I have to leave them off. So only the common numbers, common factors. Common factors. So 2 times 2 is 4. So the answer for this is 4. 4 times 3 is 12. 4 times 5 is 24 is the highest common factor. Because 2 is also a common factor of 12 and 20. But 4 is greater than 2. So it's the highest common factor. Similarly, 28 and 56. 28. 2 times 14 and 2 times 7. Similarly, 56 is actually 2 times 28. 2 times 14 and 2 times 7. So 28 is equal to 2 times 2 times 7. Now when you take 56, that is equal to 2 times 2 times 7 times 2. Since there is a common number, I'm rearranging this and writing it as 2 times 2 times 7 times 2. Now I just have to take what is common to both of these two numbers. 2 is common times 2 is common times 7 is common. But this 2, there is no 2 here, corresponding 2 here, so I'm not going to take that. So this is the highest common factor of 28 and 56, which will come to 2 times 2 is 4, 4 times 7 is 28. So the highest common factor of both of them is 28. 28 times 1 is 28 and 28 times 2 is 56. Now we look at the second method. You can choose which method you like and do this. Now to find the HCF of 12 and 20, I'll write them like this. And now I choose a small number that can divide both of them. The smallest number I can think of is 2. 2, 6, 12. 2 times 10 is 20. Again continue. 2 can divide both because these are even numbers. 2 times 3 is 6. 2 times 5 is 10. These are prime numbers. 3 and 5 are prime numbers. So we cannot divide them further. So now what I have to do is just whatever is here. Forget about those things that are here. Whatever is here, only that should be taken. So that is 2 times 2. So 2 times 2 equals 4. This might look simpler for some of you, so you can just use this method. Do the same for 28 and 56. 28, 56. So both are even numbers. So 2 times 14 and 28. 2 times 14 is 28. 2 times 28 is 56. Then 2 times 7 is 14. 2 times 14 is 28. Now, For a number that can divide both of these is 7. 7 times 1 and 7 times 2 is 14. Similarly, remember, we only take what is on this vertical line, vertical segment here. Whatever is here, that's what we need to take. So that is equal to 2 times 7, which is 2 times 2 is 4, 4 times 7 is 28. So that is the highest common factor. So this is one method, whereas what you saw earlier was another method. So you can, whichever method you find it easier, you could use. Now we are going to see something very similar to that. This is called LCM, or the lowest common multiple. All these are very interrelated, and that's why I included all of them in this video. We have seen about multiples of numbers. And what are the common multiples of two numbers? And again, what is the lowest common multiple of the two numbers? Say for 2 and 4, the lowest common multiple is 2 times 2 is 4, and 4 times 1 is 4. So that is the lowest common multiple. See, the multiples of 2 and 4, if I write multiples of 2 is 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. Here, multiples of 4, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16. If you go on, you will find that there are many common multiples. You see here there is 8 and 8. These are common as well, but we are looking for the lowest common multiple. So which is the lowest in this? That is this. So the lowest common multiple is 4. Now finding the LCM of the following, there again you have two methods just like what we saw earlier. 12 and 20, I can actually write it as 2 times 6 is 12 and 2 times 3 is 6. Similarly for 20, these are prime factorization methods that we did earlier. 2 times 10 is 20 and 2 times 5 is 10. So I'm going to write them together here. 12 is equal to 2 times 2 times 3, 2 times 3, and 20 here is written as 2 times 2 times 5. Remember to write it separately because there we just leave a blank so we know exactly there is no number here that corresponds to this. And now we write whatever is common. We, like, there are two 2's here, but we only use 1 2, just like the HCF, times. And then we take this 2 here, times. In this case, even if you have 1, we take that, times 5. So this is the lowest common multiple of 12 and 20. What is this? Let's check. 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60. This is equal to 60. So the answer is 60. Now let's just quickly double check 12 and 20. Let's look at the multiples. 1, 2, 3, 4, 5, 6, 7, 8, 1. 12 times 1 is 12, 2 is 24, 3 is 36, 4 is 48, 5 is 60, 6 is 72, goes on. We will continue here. 20 times 1 is 20, times 2 is 40, times 3 is 60, times 4 is 80, times 5 is 100. Now, from the lowest, we are looking for the lowest, so we start from here, start scanning, whichever number comes first common. The first common number that you get here is 60. So that matches with our answer here. So 60 is the lowest common multiple of 12 and 20. Now let's do for 28 and 56. 28, 2 times 14 and 2 times 7. Similarly, 56, 2 times 28, 2 times 14, 2 times 7. So we're going to write 28 is equal to First, 28 is equal to 2 times 2 times 7. So 2 times 2 times 7. And this is 56. That is equal to 2 times 2 times 2 times 7. I'm just going to rearrange it, times 7 times 2. So for each common number, we take one number here, times 2 times 7 times 2. So this is the lowest common multiple. So this is 2 times 2 is 4, 4 times 2 is 8, 8 times 7 is 56. So the lowest common multiple is 56 here. Hope this was clear. I think this is method 2, but this is for LCM. Sorry about that, something missing. So the second method for finding the LCM is this: 12 and 20. Write them down like this. Both are divisible by 2. 2 times 6 is 12. 2 times 10 is 20. Similarly, 2 times 3 is 6. 2 times 5 is 10. And we cannot further divide them. So I can stop here. One thing is, I can continue. In this case, for LCM, I will take both the horizontally whatever is present and finally vertically whatever is remaining. So 2 times 2 times 3 times 5. That is 2 times 2 times 3 times 5. 2 times 2 is 4. 4 times 3 is 12. 12 times 6 is 60. So that is the answer. So if it is 28 and 56, two times 14, 2 times 28, 2 times 7 and 14, 7 times 1 and 7. So again, we take all of them. So that is 2 times 2 times 7 times 1 times 7. So that is 2 2's 4, 4 7's, or 7 times 7 is 49, 49 times 4. Let's check. 49 times 4. 196. Oh, I made a mistake. 7 times 2. Just thinking something is so amiss here. 7 times 2 is 14 here. It's not 7 times 7. So this should also be 2. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2, 7, 8. Sorry, 8 times 7. 7 times 8 is 56. So this is the lowest common multiple. Sorry. Hope this was clear. If you find this useful, please comment your feedback, because that helps me to know that if whatever I'm doing is really helpful to you. If it's not helpful, please do comment on that as well. So if you find it useful, share it with your friends, subscribe to my channel so that you can get notified whenever I upload new videos. Have a great day. Happy learning. Next video, we will see the applications of these practical problems where we can use LCM, HCF, and all these. Thank you very much. Have a great day. Bye.